With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Our question is, which of the following have highest magnetic moment? Over here we are given 4 options: Fe2 positive, Mn positive, Fe3 positive, and Fe positive, and we are supposed to tell that which of the following has the highest magnetic moment. Right now, first of all, what is magnetic moment? Magnetic moment is the measure of the object's tendency to align with the magnetic field. Right, object's tendency to align with the magnetic field. Right now, formula that we use to calculate magnetic moment in ions, this mu magnetic moment is equal to n into n plus 2 whole under root, right, where n are what? N are the number of unpaired electrons. N is equal to number of unpaired electrons, right? So one by one we would take these ions and find out how many unpaired electrons are present in them. Accordingly, we would see which has the highest magnetic moment, right? So what we can say that the magnetic moment value is directly proportional to n, that is number of unpaired electrons. The more are the number of unpaired electrons, the greater would be the magnetic moment. Now if we take the first case, that is iron 2 positive, right? Now we know iron has a valence electronic configuration of 4s2 3d6, right? Now removal of 2 electrons would take place from s orbitals, so this would be 4s0 3d6, right? Now if we suppose, see, this is our d orbitals, right, and the 6 electrons would be present like this. So over here we have 1 2 3 and 4 unpaired electrons. N value becomes 4 over here, right? So mu would be equal to, our magnetic moment would be equal to 4 into 4 plus 2, that means 6. So it would be 4 into 6 under root. This is equal to under root 24 Bohr magneton, right? Now in the second case we have Mn positive. Now what is manganese? Manganese has a valence electronic configuration of 4s2 3d5, right? Now 1 electron is lost, that means Mn positive. So Mn positive would be what? 1 electron would be lost from here, so it would be 4s1 3d5, right? So over here we would have 1 unpaired electron present in s orbital, and then we have d orbitals, and 5 unpaired electrons are present over here. So we have total of 6 unpaired electrons in this case, right? So what would be magnetic moment? It would be 6 multiplied by 8 under root, right? So this becomes under root 48 Bohr magneton, right? This is greater than the first case. Then if we look at our third case, which is iron 3 positive. Now iron is what? Again, iron is 4s2 3d6, and iron 3 positive would be what? It would be 4s0 3d5. Now we have over here 5 unpaired electrons, right, like this, right? So n value is 5. So what would be our magnetic moment? It would be 5 into 7 under root. This would be equal to under root 35 Bohr magneton, right? And if we see our next case, which is iron positive, iron positive would be what? It would be 4s1 3d6, right? So we would have 1 unpaired electron over here, and then we have 6 electrons present in d orbitals like this. So 1 unpaired electron over here and 4 over here. So n value becomes again 5. So our magnetic moment again comes out to be under root 35 Bohr magneton, right, which is same for this case. Now in amongst these fours, the maximum magnetic moment comes out to be in this case, that is second, right, and the value is under root 48 Bohr magneton. So our answer would be second, right, that the second case, that is our Mn positive, would have the maximum magnetic moment. Why? Because it has maximum unpaired electrons in it, and the number of unpaired electrons it has is 6, right? So we have maximum unpaired electrons, and that is why the highest magnetic moment would be of Mn positive. So our answer to this question would be second, not iron 2 positive, not this, not this, it would be second.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.